Modern air combat is no longer fought within visual range. Long before opposing pilots can see each other, radar systems have already detected, tracked, and classified targets hundreds of kilometers away. In this environment, victory often belongs to the pilot who can launch first, guide accurately, and strike before the enemy even realizes the danger. Today we'll explore India's beyond visual range missile arsenal, from Soviet-era weapons that laid the foundation of Indian air combat to some of the most advanced missiles currently in service, and finally, the indigenous systems that may define the future of Indian air power. BVR stands for Beyond Visual Range. Instead of relying on eyesight, modern fighter aircraft use powerful radars and sensors to detect enemy aircraft at great distances. Once a target is identified, a missile can be launched long before either pilot sees the other. Every BVR engagement depends on three key factors: detection, guidance, and energy. Detection determines who sees first, guidance determines whether the missile reaches its target, and energy determines whether the missile still has enough speed and maneuverability left to score a kill. India's BVR journey began with the Soviet-designed R-77 family. Introduced on aircraft such as the MiG-29 and later the Su-30, the R-27 came in several variants with engagement ranges extending from roughly 50 to 130 kilometers. Some versions used radar guidance while others employed infrared seekers. However, many R-27 variants relied on semi-active radar homing. This meant the launching fighter had to continuously illuminate the target throughout much of the engagement. While effective for its era, this reduced tactical flexibility and forced the pilot to remain committed to the engagement for very long periods. Nevertheless, the R-27 family represents India's first major step into beyond visual range warfare. The next major revolution arrived with the R-77 family. Unlike the R-27, the R-77 introduced active radar homing. Instead of relying entirely on the launching, the missile could activate its own radar during the final phase of the flight and search for the target independently. This dramatically improved engagement flexibility. Pilots could launch, maneuver, and focus on surviving rather than continuously guiding the missile. Depending on the variant, engagement ranges extended from roughly 80 to 160 kilometers. For years, the R-77 became one of the Indian Air Force's primary BVR weapons and remains an important part of the arsenal even today. As India's Air Force modernized, diversification became increasingly important. This led to the adoption of Israeli air-to-air missiles, particularly the Derby family. The Derby and later the iDerby-ER introduced modern active radar guidance and improved engagement performance. Depending on the variant, engagement ranges extended from around 50 km to well over 100 km. These missiles form an important part of the Tejas arsenal and provide India with a capable non-Russian BVR option. More importantly, they reduce dependence on any single foreign supplier. While Tejas gained Israeli BVR weapons, India's Rafale introduced an entirely different family of missiles, the MICA family. Unlike many air-to-air missiles that rely on only one guidance method, the MICA is available in both radar-guided and infrared-guided variants. This gives pilots greater flexibility depending on the tactical situation. The radar-guided MICA can engage targets using active radar homing. Meanwhile, the infrared variant tracks heat signatures and can be particularly useful in situations where minimizing radar emissions is desirable. When discussing beyond visual range combat, one missile consistently stands apart: Meteor. Widely regarded as one of the most capable operational air-to-air missiles currently in service. Unlike conventional missiles that burn through their fuel rapidly before coasting towards the target, Meteor uses a ramjet propulsion system. This allows it to continue generating thrust throughout much of its flight. And that changes everything. Because range alone does not determine effectiveness. A missile that reaches the target with high energy remains dangerous much longer than one that has already slowed down significantly. Meteor's engagement range is commonly quoted at over 150 km, but its true strength lies somewhere else, in a concept known as the no escape zone. This is the region within which a target has little chance of successfully evading interception. Thanks to its ramjet propulsion and exceptional energy retention, Meteor is believed to possess one of the largest no escape zones of any operational BVR in the world. Despite the capabilities of imported missiles, India's long-term objective has never been dependence. The goal has always been self-reliance, and that brings us to Astra, India's first indigenous beyond visual range air-to-air missile program. Astra Mark I entered service with a range of approximately 110 km and active radar guidance comparable to modern foreign systems. Integrated onto aircraft such as the Su-30 MKI and Tejas, Astra marked a major milestone in India's defense industry. But Astra was never intended to remain a single missile. It became a family. Astra Mark II is expected to extend engagement ranges to around 160 km while improving seeker performance, engagement flexibility, and overall combat effectiveness. Beyond that lies Astra Mark III, often referred to as the Gandiva missile. Unlike conventional rocket-powered missiles, Astra Mark III is expected to employ solid fuel ducted ramjet technology. This allows the missile to continuously produce thrust throughout a much larger portion of the flight. As a result, projected engagement ranges may exceed 300 km. More importantly, the missile is expected to retain significantly more energy when approaching its target. If successful, Astra Mark III could place India among a very small group of nations capable of fielding advanced ramjet-powered air-to-air missiles. For the first time, India is not merely operating advanced BVR missiles, it is designing them. To understand how these missiles compare, let's take a quick look at India's current BVR arsenal. Looking at this table, it may seem obvious that missile with the largest range is automatically the best, but modern air combat is far more complicated than that. Radar detection range, data link quality, seeker performance, electronic warfare resistance, energy retention, and no escape zone all play crucial roles. A missile cannot engage a target that the aircraft cannot detect, and a missile that reaches the target area with little energy remaining may still fail against a maneuvering opponent. In modern aerial warfare, the missile itself is one part of a larger kill chain. From Soviet-era R-77s to the formidable Meteor and the rapidly evolving Astra family, India's beyond visual range arsenal has undergone a remarkable transformation. What once depended almost entirely on foreign technology is increasingly being supplemented by systems designed and developed at home. Today, the Indian Air Force operates one of the most diverse collections of air-to-air missiles anywhere in the world. With the Astra Mark II, Astra Mark III, Tejas Mark II, and the future MICA on the horizon, the next chapter of India's air combat story may well be written by missiles made in India. The battle of the future may begin hundreds of kilometers apart, and India is steadily ensuring it has the tools to fight and win them.